Mr. Robs here, and we're working on sinusoidal applications with trigonometry here. So here's a word problem here. The city of Prague in January, the first month, so month 1, has the coldest average high temperature for the month of 2 degrees Celsius. And July, the 7th month, the warmest month, has an average high of 26 degrees Celsius. Place the temperature information on the graph above to sketch a graph of the average high temperatures over the course of the year. All right, so at 2 degrees, here's January, here is 1, 2, and it's a min. And I also know the maximum is 726. So that is going to be up here. This is 726, and it is the maximum. All right, and so now the average high temperature follows a periodic pattern each year, and it has the model of this particular function here, cosine. H is the average high temperature in Celsius, and T is the time in months. Write down the values of A. So if this is the bottom, it means the graph is going like this and then back down again. And so this here, I recognize that if I want to find the A, if I look for the middle here, if I can find my principal axis, if I go from 26 to 2, that is a difference of 24. And if I divide that by 2, 24 divided by 2 is going to be 12, which is my A value. And so I go the difference, 26 minus 2, divided by 2. If I want to find my D value, well, that's in the middle. I want to find the average between those two. So as opposed to subtracting for D, I will add these two together. And that will give me 28 divided by 2 is 14. And so my principal axis is going to be at 14. Here is going to be my principal axis. And let's change that color so it's prettier. Okay, so now here's my principal axis. D is 14. Now C, because it's cosine, the C value is just where the maximum is. And so the C value is going to equal to 7. It's always just the maximum. The C is easy to find for cosine. Now show that B is pi by 6. Well, if I consider this, I know from 1 to 7 is half a period. And so a full period, which is 1 year, is 12 months. And so the B value is equal to 2 pi over the period, which is 2 pi over 12, which is pi by 6. And whenever you have to show that, make sure you overemphasize the work that you do so that it's very clear to the reader that they know what you're doing. So now we have our equation. What we can say is that y is equal to D, which is 14, plus 2 cosine pi by 6 x minus 7. Okay, and I'm going to check in my calculator to make sure this is correct. And so if I go here, I'm going to go 14 plus 2 cosine. I'll put a fraction in. And we'll put in pi over 6. Make another parenthesis to go x minus 7. Okay, I'm going to make sure that I'm in radians because that's default now. And my window, I make my window fit here. So my x goes from 0 to 12. It's going to go by 1s as the scale, and then I'm going to go from -2 to 28, -2 to 28, and then the scale of 2. And let's see what we get. Oh, something's not quite right. You can see that something's not quite right. Let's see what I have in here. 14 plus 2. Oh, not 2, 12. This is 12. So I have to insert my 12. Insert. And so that's why it's always good to check that your graph and the calculator tell you some, oh, now we're talking. This looks much better. And actually the other typos, this should not be x. This is not really y, but either h and t. So this is actually h of t is equal to, and This is T to be good with notation. And so the last final check I'll do is I'm going to trace. If I hit trace, I want to see that 1 gives me 2, and that 7 gives me 26. And that is indeed true. So now I'm ready to do h of 12. And so h of 12 is simply, I just plug this in here, I trace the value for 12, kaboom, and I get 3.6, 1 to 3 significant figures, degrees Celsius. And so this is the average high temp in December, as December is the 12th month. Okay, so now it says Mr. Rops, vegetables grow in Mr. Rops' garden when the average high temperature is 21 degrees or higher. How long is the vegetable growing season in a typical year? Well, in order to do it, I need to solve this equation for 21. And if I think graphically, I'm going to take my principal axis here, I'm going to move it up to 21. And so I can see that from these months here to here is where this is the time when my vegetables will grow. So I want to find how long it is, so I'm going to put into my calculator, I'm going to put into this 21, and I'm going to graph this, and I'm looking for the points of intersection. And so if I find, I'm going to trace, intersect, and I get 5.189, and so the first t is equal to 5.189. And the second t, we do it again. We go second, I'm going to do the intersection, 1, 2. The guess, I'm going to put over here closer to November. And that tells me 8.81 is equal to 8.8104. So how long is the vegetable growing season? If I subtract these two values, so I'm going to go 8.8104, subtract the 5.189, and I can see that it is 3.62 months long to grow vegetables. Okay, and so that's what this is here. Another application, just being able to read the scenario, pick out the information, and answer the questions from the context.